we have to find the equivalent resistance point between points A and B. All the resistances given here have the same magnitude, let's say R. Now if we look at this circuit carefully, you'll realize that the entire circuit is symmetric about the line AB, this horizontal line AB. So in order to solve this question, what we can do is we can fold one half of the circuit so that it completely superimposes with the other half. Now let's say we do that, we need to keep in mind which all points coincide. For example, if we fold the upper half of the circuit with respect to point AB, then this point will coincide with this point. This point will coincide with this point. This point will remain the same as it's on the line AB. This will remain the same. This will remain the same. Which means as soon as this coincides with this one, this coincides with this one, this resistance and this resistance will become in parallel. This resistance and this resistance become in parallel. This resistance and this resistances become parallel. This and this come in parallel, and this resistance and this resistance also come in parallel. Which means if I were to redraw the equivalent circuit, I have A, and then now as I told that these two are parallel, this becomes effectively R by 2. Now this is also R by 2 because this and this resistance are in parallel. Similarly, this becomes R by 2 because this and this resistance are in parallel. This remains R, right? This also remains R because this lies in the same line as the line of symmetry. This also becomes R by 2 because this and this resistance are in parallel, and similarly this also becomes R by 2. Now if you look at this circuit and consider this point, we realize that the current flowing through this resistance is the same as the current flowing in this resistance. Similarly, the current flowing in this resistance is the same as the current flowing in this resistance, which means this junction seems to be a junction, but it is not a junction, it's a pseudo junction, which means I can isolate this part. So my new circuit will look something like this. This is R by 2, this is R by 2, this is R by 2, and this is isolated. This is R by 2, this is R by 2, this is R. Now these points are isolated now. This is R, this is point B, this is point A. Now this R by 2 and this R by 2 in series are, and this is in parallel with R by 2. So R and R by 2 in parallel become R by 3, and then R by 2 and R by 2 in series. So effectively we have R by 2 plus R by 2 plus R by 3, which is 4R by 3. This is in parallel to R and R series, which is 2R. So the equivalent resistance come out to be 8R by 10, which is nothing but 4 by 5R. This is our final answer.